Okay, so the first thing I'm going to do in order to sketch this normal curve is to draw an axis. So of course it's going to be a horizontal axis, and so it's just a flat line. Now on this axis there are some points that are particularly important. Possibly the most important one is to mark on the mean of the normal curve, because that tells us where the highest point is. The other things we would like to mark on this axis are the points that are 1 and 2 standard deviations away from the mean. So because our standard deviation here is just 1, the point that is 1 standard deviation to the left of the mean is going to be somewhere over here. I'll put it there, and it's going to be at 4. The point that is 2 standard deviations to the left of the mean is going to be then over here, and that'll be 3. And I also need to mark on the points that are 1 and 2 standard deviations to the right of the mean as well. So we have 6 and we're going to have 7. And why not, just for luck, I'll mark on the points that are 3 standard deviations from the mean as well. Now because this one is so important, I'm going to be a bit particular, and I'm going to emphasise the fact that it's the mean with a dashed line going up there, and the same for the points that are 1 and 2 standard deviations away. Because we're actually being told to do that, mark on the graph with dotted lines the points that are 1 and 2 standard deviations away from the mean. So that's setting up for the normal curve. Now the normal curve always has its highest point at the mean. So here we're not actually going to bother drawing a vertical scale, so it doesn't really matter where the highest point is. But let's just suppose we put it there. That'll do. And the other thing that makes the mean so important is that the normal curve looks the same on both sides of the mean. So in other words, we say it's symmetric about this mean point. And away from this mean point, away from the highest point, the normal curve gradually reduces in both directions. Something like that. So this normal curve should be flat on the top and look approximately the same on both sides. Now see how between 1 standard deviation to the left of the mean and 1 standard deviation to the right of the mean, this normal curve sort of looks like a sad face. It looks a little bit sad there. When the curve gets to these points that are 1 standard deviation to the left and the right, suddenly the normal curve stops looking like this, but instead starts curving back around the other way. So it'll start doing something a little bit like this. And same on the other side. Something like that. So you see how the curve is going back this way. So over here it looks more like a sort of happy face, and same over here, whereas over here it's a sad face. Once it gets to about 3 standard deviations away from the mean, it just goes to 0. Well, almost 0, not quite, but it gets closer and closer to 0 the further out that way we go, and it gets closer and closer to 0 the further out this way we go as well. Now we're not asked to do this, but something else I think I'll just put on my normal curve here is the areas in each of these sections. So it doesn't matter, it turns out it doesn't matter what the mean of your normal distribution is, and it doesn't matter what the standard deviation is either. The area between the mean and 1 standard deviation away is always 0.341, and so it's going to be the same on this side. And between 1 standard deviation from the mean and 2 standard deviations from the mean, it's always 0.136. And same over here, it's always 0.136. And then in the tail bits off to each side, so the area from here out to like forever, out this way, that's going to be 0.023, and same in here. So you don't really need to remember these numbers as such. I've just put them on there just because I liked just to label up with the area. So the person, whoever's looking at this diagram, can just see how big each of these sections should be relative to each other. So clearly I haven't really drawn these up to scale, so it's just helpful just to label them up with the area. But you won't have to do that on the test, as long as you can draw up a curve that looks something like this, and it has the high point at the mean, and it has the point where it changes from curving around this way like a sad face to curving this way like a happy face. As long as you put that point at 1 standard deviation away from the mean, and as long as by about 3 standard deviations from the mean the normal curve is pretty much 0, going to 0, then that will be just fine. So after we do that, we're asked to do pretty much the same thing all over again. So let's do that. It's just exactly the same thing again, except now we've got a different mean and a different standard deviation. So now we're told that the mean is going to be at 6 instead of 5, and the standard deviation is now 2. So the point that is 1 standard deviation to the left of this mean is going to be 4. The point that is 2 standard deviations away from this mean to the left, we need to go 1 standard deviation, 2 standard deviations. So this will be 2. And same going back the other way. 1 standard deviation this way is going to take us to 8. Another standard deviation that way will take us to 10. And another standard deviation this way will take us to 12. Another standard deviation this way will take us to 0. So let's once again put on a dashed line to mark the location of the mean, and let's also put on some dashed lines to mark on the locations of the points that are 1 standard deviation away from that mean on either side. And same with the points that are 2 standard deviations away from the mean, just like we've been asked to. So if you're observant, you'll see that, well, this looks almost exactly like I had before. The only difference is that the mean is now in a different spot. So I've just labelled the mean point with a different number, and the points that are 1 and 2 standard deviations away, they look the same as well, but now the difference is just going to be 2. The gap between them is just going to be 2 instead of 1. So really, I've just used a slightly different scale for my x-axis. Instead of 3 of these little squares representing 1 unit, they're now just representing 2 units. So when I draw up my curve, it's going to be exactly as I had before, exactly as we had before, hopefully. We're going to start by putting the high point there, and then we want to make sure that it curves downwards like this in both directions away from that high point. And then at 1 standard deviation away from the mean on either side, this curve just has to start going back the other way again. Whoops. Something like that. So really, it just looks exactly the same as I had before. In fact, these areas are also going to be identical. So pretty much everything's exactly the same. It's just that the numbers on this axis change. So if you're asked to draw a normal curve in a test or something, then you can always just pretty much draw the same thing. Just be careful how you label up your axes.